The idea of turning night into day became a reality the moment the light bulb was invented. With the onset of darkness, millions of lights fill streets and homes with bright illumination. In early 1880, Thomas Edison founded the first company to produce incandescent lamps. Together with a team of scientists, he managed to achieve a lamp lifespan of over 1/200 hours. This was the technological breakthrough of that era. Later, General Electric scientists used inert gas to fill the glass bulbs, which significantly increased their operating time and light output. Little has changed since then. The light bulb manufacturing industry remained stagnant for an entire century. People often wondered, how can we save electricity? It was only in the 21st century that a revolution occurred in the world of lighting. Light bulbs became significantly more efficient and durable. So, how are modern light bulbs made? To understand how energy-efficient light is produced, we visited the workshop of LED Solution LLP, where LED lamps are manufactured. It all starts here. This is the machine for applying liquid tin to the circuit board. First, a stencil is installed. It is different in every case and must match the board design. Then, the technician places the corresponding board onto the carriage. The upper press descends, and the technician applies liquid tin to the built-in stencil. This is the solution used to mount LEDs to the board. Using a specialized blade, excess tin is removed so that a coating less than 1 millimeter thick remains on the board. Next, the SMT machine takes over, using reels that resemble a film projector. These are, in fact, the LEDs themselves. The board with the applied solution is placed on a special carriage. The operator sets the program on the computer, and the process begins. We input the parameters through a computer installed on the SMT equipment. The main parameter depends on which fixture the board is intended for. The equipment calculates the precision for placing the diode onto the board. Between 10 and 90 diodes are used on each board. This equipment is responsible for positioning them in the exact order. Specialized nozzles vary for different diodes, depending also on the type of board. The SMT machine itself operates on a vacuum principle. First, the board is fed in, and the machine mounts the diodes using built-in pumps. Thus, diode by diode, the entire board is filled. This machine's operation resembles scenes from a sci-fi movie about space technologies. Throughout the process, the operator monitors the air sensors and checks the pressure. It must not drop below 0.4 megapascals, otherwise the machine simply will not function. Errors in the process can also be identified by a built-in light indicator. A green light means the work is proceeding according to plan. Yellow indicates that attention is required. Red signifies a process error. The operator then checks all parameters via computer to resolve it. Next, the board with the mounted diodes is sent to the oven. Parameters are also set for the oven. It has its own computer that determines the temperature for each board based on its properties, defining the required heat for every centimeter. The oven's program is computer-controlled, while the conveyor speed is set manually. The temperature changes at every stage as the board moves along the belt. It is 210 degrees at the entrance, 250, 270 degrees in the middle, and 210 degrees again at the exit. Once the board is ready, the fixture assembly process begins. We will demonstrate the process using a 60x60 fixture as an example. The first assembly stage takes place in the mechanical shop. This involves cutting the glass, the profile, and the housing. A profiled sheet is used for the fixture's base. It is marked according to the fixture's specifications. For instance, for a 60x60 fixture, the marking is set at 573 millimeters. To assemble a 60x60 fixture, you need specific components: a metal plate, the housing profile, and the glass, the light diffuser. Everything is made here in this mechanical shop. First, the sheet is taken, precisely marked according to dimensions, and cut using a guillotine. The profiled sheet is manually aligned so that the marks match the machine's blade edges. This mechanism is called guillotine shears, or simply a guillotine. It is semi-automatic and designed for cutting metal with a thickness of no more than 1 millimeter. The shears are triggered by a foot pedal. Next, the fixture housing is cut. For this, the profile is removed from its packaging film and placed on special supports. The protective film is stripped from the profile. Before cutting the metal, the shop foreman puts on a safety mask to protect his eyes from metal shavings and wears ear protection. The profile is cut according to a preset template using an aluminum profile saw. Once all blanks are ready, the lamp assembler begins his work. Markings are made on the fixture base according to specified parameters, using a pre-made template. Then, holes are drilled, and the LEDs are installed using a riveting tool. The driver, or more simply the power supply, is also attached to the base. Contacts are soldered and connections are verified. The wire is attached loosely to prevent tension during transport or handling, which could lead to a break. After checking all contacts, a grommet is inserted and the wires are passed through it. The grommet is used to prevent the metal edges from cutting the wires. Now we proceed to the housing assembly. For this, corner pieces are screwed to the profile and 3 sides of the fixture are installed. The glass and the plate are inserted into the grooves. The entire assembly process is done by hand, which eliminates the possibility of defects. Finally, the 4th side of the frame, the cover, is attached. To provide additional structural strength, extra holes are drilled and fasteners are inserted using a pneumatic riveter. As a final touch, a metal eyelet or bracket is screwed on. The fixture is ready, and now it's time to test its performance. We place the fixture into a sphere-shaped piece of equipment called a Spektron. We connect it. There is a reflective surface at the back and a light-absorbing surface at the front. We close the sphere to prevent any sunlight or ambient room light from entering. Once closed, we check the characteristics, power consumption, voltage, and current. The fixture has passed the quality control, QC, test. Here are some of its main characteristics. LEDs do not contain harmful substances. Today, this is one of the most advanced lighting technologies. Unlike fluorescent lamps, LEDs do not flicker and do not require high voltage, making them safe to use. While standard bulbs last about 800 hours, such a fixture can serve for up to 50,000 hours. Buy quality products made in Kazakhstan.